Hello everyone. Welcome to the e-learning space of data science for public policy. This video is brought to you by the DSPS Data Science and Policy Studies program under the Chinese University of Hong Kong. This video is supported by the CUHK Courseware Development Grant Scheme. Our topic for this video is about descriptive statistics. We are going to have a revision on the measures of central tendency, measures of dispersion, then we will move on to box plot and some policy implications. First, let's talk about measures of central tendency. Three common measures are mean, median, and mode. So on the right-hand side, we have a warm-up example. So for mean, it's also called average, which is the average value. So we have to add all the data points we have divided by the number of data we have. So on the right-hand side example, here the mean would be 5 candies because we first have to add the 3 data, which is 1, 2, and 12. And after adding them together, we divide it by 3 because there are 3 data points. And for median, first we have to arrange the data from low to high values, and then we look for the value at the middle. So for this example, the median would be 2 candies. And for mode, mode is the value which occurs most frequently in your data set. Next, let's talk about measures of dispersion. So to measure dispersion, we can look at range, interquartile range, variance, and standard deviation. Range is the absolute difference between maximum and minimum value. Interquartile range would be the difference between the first quartile and the third quartile. Variance is the average of squared deviations above the mean. And standard deviation would be square root of the variance. Let's look at example to get familiarized with the 4 measures of dispersion. First, we have example 1 here, which has a data set of 10 values, which are 1 to 10. The range would be the absolute difference between the maximum and the minimum value, which is maximum value subtract the minimum value, which is 10 minus 1, which gives you 9. And for interquartile range, first we have to locate the median. So here, since the data is already arranged from low to high, then the median would be the value at the middle, which is 5 plus 6 divided by 2, which is 5.5. After we get the median, then we can think about dividing the data set into 2 halves, which is the lower half and the upper half of below and up and above 5.5. First, at the left-hand side of 5.5, we have 1, 2, 3, 4, 5 data points. And the center of these 5 data points is 3, and therefore your first quartile is 3. Similarly, if you look for the third quartile, then on the right-hand side of your median, 5.5, then you have 5 data points, 6, 7, 8, 9, 10. And the center of these 5 data points is 8, and therefore your third quartile would be 8. And the interquartile range would be the third quartile minus the first quartile, which is 8 minus 3, and that gives you 5. Let's look at the second example to find the variance and standard deviation. Here we have a small data set of only 9 values, which is from 1 to 9. In order to find the variance, first we have to calculate the mean. So again, mean is the average value, which is the sum of all data divided by the number of data. So which is 45 divided by 9, that gives you 5. So this is your mean. And then we have to look for the squared mean deviation. So if you look at the table, now we have the original number, which is 1 to 9, your original data points. And then on the second row, it's number minus mean, and the mean is 5. So this is called the mean deviation. So this is calculating how far each of your data points is located from the mean. So it's basically your original number minus 5. And therefore, if your number is 1, then the mean deviation in the second row would be minus 4. And if your original number is 9, then your mean deviation would be positive 4. And then after we calculate the mean deviation, then we have to square this mean deviation. And therefore, on the third row, we're squaring the second row. So for minus 4 on the left, then squaring it gives you 16. And all the way to 9, the mean deviation would be 9 minus 5 equals to 4, and the square root of the mean deviation would be 16. So after we compute this table, then we have to get the sum of squared mean deviation, which is 16 plus 9 plus 4 plus 1 plus 0 plus 1 plus 4 plus 9 plus 16, and that gives you 60. Recall that variance is the sum of squared mean deviation divided by n, where n is the number of the data you have. And here we have 9 data, and therefore your n is 9. So variance would be 60 divided by 9, and that gives you 7.5. To calculate standard deviation, it's the square root of variance, and therefore you can just simply take the square root of 7.5. If you take 3 significant figures, that gives you 2.74. Next, let's move on to box plot. So before we plot a box plot, first we have to gather some data. So here in the following example, we're going to use the data source from the partner net. So if you follow the link, you can go to this web page, which is the partner net by the Hong Kong Tourism Board. And inside the website, if you go to research and statistics, you can look for some document which is called visitor arrival statistics, and they are available in PDF and Excel format. So after you gather the data, then you can get something like this. So here in the Excel file, we have column A, which is called time, and each time are the months of interest. So we have a period from January 2016 all the way to December 2020. So these are the months that we are interested in. And then for column B, we have total VA. VA stands for visitor arrival. So these are the numbers corresponding to each month, that how many visitors have arrived Hong Kong. So after we gather these data into the Excel format, then we can start typing some data codes to load the Excel file. First, you type import Excel, and then you can type the path of where your document is located in. So this is your local computer path of your document's location. And then after that, we can load the data into Stata. And then next, you have to do a TS set time. So remember, our column A is called time, which is our months. And then TS set is a command that is used to let Stata recognize your time variable. So here we are teaching Stata that our time is the variable that corresponds to the period of the time, or the time that we study. And then in order to plot the line plot on the right, we can type the command codes as TS line, which stands for time series line, and then our variable of interest, which is total VA, and then comma. And after the comma, we can set some graph aesthetics to make the graph looks nicer and more informative, such as adding a title or hiding some of the title. And after we plot the graph, we might also want to look at the descriptive statistics. So instead of looking at each number, the number of visitors arrived at each month, we can generate a variable called period, where period is a category variable. So it takes values from 1, 2, 3, and each of them refers to the normal times, extradition bill times, and the COVID-19 times. So how to do that is, first we have to type GEN, which is generate, period. Period is our new variable name, equals to, and then equals to a string which is 1 point normal times in quotation, in the quotation. And this means that we are going to categorize those times as normal times if the time variable is within the range from 1st of January 2016 to the 31st of May 2019. And after that, we want to add another value for period. Then we type replace period, and then period will be equals to 2.e bill times if the range of the time is within the 1st of June 2019 to the 31st of January 2020. And then thirdly, we can also add a value in the period variable, which is called 3.COVID-19 times. And we can define this COVID-19 times as a time period, that any time variable is between the 1st of February 2020 all the way to the end of by the year end of 2020. And after we set up this free period, and then we can look at the statistics separately in each of the periods. So first we type sum, which refers to summarize, and then we summarize the total VA variable if period equals to 1 normal times. So this is talking about we are looking at the descriptive statistics of total VA only in period equals to 1 normal times. And note that by the end of this code, there is a comma and then a D. So the D is the setting that allows us to look at the details of this summary. So below it, there is the output table, which summarizes the total VA numbers within period equals to 1. So here we can see there are percentiles, there are 4 smallest and 4 largest values. And then we can look at the number of observations, 41, and there is the mean, standard deviation, and variance calculated for you. Next, if we want to do a similar thing for period 2 and period 3, we can also type summarize total VA if period equals to 2 EVO times or equals to 3 COVID-19 times, and we set the data setting to be D, which is detailed. And then we can have the 2 table on the left-hand side, and this also gives you the number of observations, mean, standard deviation, variance, and the percentiles. And then at the very bottom of the left-hand side, we have the graph code, which is how to plot the box plot on the right-hand side. So in order to plot the box plot on the right-hand side, we can look at the very bottom left, which is the code start from graph, which is to plot a graph. And then we specify the graph type, which is box, because here we want to plot a box plot. And then we type the variable of interest. Here is total VA, and then comma, and then over period. So instead of automatically taking time as our variable, we can look at a period, which is only to compare 1, 2, 3 period. So we are not going to have a lot of boxes, one for each month. So this would be an easier way for us to visualize the changes between normal times, EVO times, and later on to COVID-19 times. And then we can also set there is no outliers if you want to add some aesthetics to your graph, also to hide the Y title, the Y-axis title, if that is something that you want to set. And if we look at the box plot, we can see that in 3 COVID-19 times, the box is really straight and also located at the very bottom. So we can conclude the policy implications are that COVID-19 is the most significant reason for bringing the tourist industry to a standstill. Inbound tourism will likely remain subdued in the near term, but may begin to recover later when the vaccination program yields the intended results. After the COVID-19 situation are put under control, it is suggested that mass media campaign could restore travelers' confidence. So this is the end for this e-learning video. Thank you.